Hi, good morning, good afternoon, and good evening from wherever you're joining. My name is Clarence, and I work as the Global Lead Instructor at Couchbase. Today, I'm going to teach you how to data model for Couchbase 7. So, agenda of the session is we're going to introduce data modeling. We're going to talk about a relational to NoSQL mind map. I'm going to show you how JSON physical modeling happens. We're going to talk about data nesting, talk about how we can make various trade-offs, and lastly, we'll talk about embedding versus referring. So let's first introduce data modeling. So what is data modeling? I had to just Google for this definition, and I got a variety of answers. So data modeling is precisely explaining a subset of information for an application using symbols or text. It is exploring data-oriented structures of an application, understanding the data semantics of an application, say identifying, documenting, and implementing the data requirements of an application. So these were all the definitions that you would see. But in short, what data modeling is, it's designing the data the way how it best suits your application. That's what data modeling is. So if you look at data modeling in general, there are three broad phases: conceptual data modeling, logical data modeling, and physical data modeling. Conceptual data modeling is basically, it's the 10,000 feet overview of your data. So how can you represent conceptual data model using ER diagrams? While logical data modeling is basically impacts your target database system or target system. Say maybe you're storing your data in document database, you're storing your data in key value store or relational or graph-based database. While physical modeling is something that is dependent on the target database. How are you going to store your data? Are you going to store in terms of relational database, or are you going to store the data as JSON documents? Okay, we're going to see most of them. When you look at data modeling for distributed system, legacy database systems were more forgiving of a bad data model because scale was rarely an issue. But if you look at the modern NoSQL systems, they are much less forgiving of a bad data model because scale is always an issue. You're always data modeling for scale, for exponential scale. So NoSQL data modeling is mostly driven by application-specific data access pattern. How are you going to ingest data from your database? How are you going to retrieve data from your database? Okay, what is the flow of your application? It's all going to impact your data model. Okay, data nesting is a first-class technique of data modeling for NoSQL systems. Okay, and this definitely requires a paradigm shift in thinking about data. But when you look at data modeling for Couchbase, you really want to know the strengths of Couchbase database system. That is, Couchbase has a key value orientation. It is memory first architecture. And most likely or very likely, you're going to store data in terms of JSON, right? And you can query your data using Nickel for query or FTS or Nickel for analytics. So you want to make use of scopes and collections for multi-tenancy. You want to duplicate and nest data when it makes sense. You want to test repeatedly to validate your design. So all these are the strengths of Couchbase Server, which you want to keep in mind when you're designing your data model, right? So let's first talk about relational to NoSQL mind map. So let's talk about this table here. So this is a very highly simplified relational table, right? So let's consider this as an order management system. So this is your order table. So if I have to see here, the order ID 123. So who placed the order? So I have to do a join here, right? And then I get to know, okay, Acme did the order and he lives here and this is his email address. Okay, what does this order ID 123 contain? These contains two items. Okay, so I'm going to do a join here again to retrieve the same thing. So this order ID contains two products, okay, with the product ID this and this. So what is this again? I need to do a join again to the product table and get, okay, this is a widget and this is a gadget. So basically order 1 to 3 is nothing but an order of 2 quantities of widgets and 3 quantities of gadgets. Okay, and who ordered this? I do a join. It was Acme. And how did he pay? He paid using PayPal. Again, there was a join here, right? So joins come with a cost. There are multiple joins that happen. So one of the several ways how I can represent this scenario in a NoSQL database is something like this, right? Let me again repeat, it's one of the several scenarios and it's not exactly this. So in your data modeling, it's full of choices, right? So look at this. There is one fetch here that I need to do. There is one JSON diagram here or a JSON document here wherein which has the ID 123 and there is an entire customer embedded here, right? And what are the items? I have an array of items that's being embedded here. And how did he pay? Using PayPal. So I have entire pay type document embedded here. So what happens now? There are no multiple joins. Instead, I do a single fetch. One fetch gets the whole document. This is just one of the several ways how you can document. So let's talk about scopes and collections, which is new in Couchbase 7.0. So if you look at the mind map here, so if you look at relational model, I can say a server is equivalent to a cluster in Couchbase and database equivalent to a bucket. So what happens here is schema is something like a scope, okay? And your table is a collection. So you'll have multiple uh, documents of the same type in the same collection, like you have that in the table. And each document is kind of a row. So what is a scope? Right? Scope is equivalent to a schema in relational database. It's a logical container for Couchbase collections. So one scope can have multiple collections. Every Couchbase bucket comes with at least one scope that is the default scope. If you don't specify any other scope, it's the default scope. You can use default containers or directly or define your own scope. Okay, so what is a collection? A collection is analogous to a table in your relational database. So every scope has a default collection. Okay, so every scope has at least one collection, which is the default collection. You can specify your own collection. So especially if you're trying to do kind of multi-tenancy. So this is an example of multi-tenancy. So let's consider I have two buckets here. So I have the sales bucket and the customers bucket. And within the within the sales bucket, I have two scopes, customer one and customer two. So basically they are different tenants here, right? Likewise, in the customers bucket, I have two scopes, customer one and customer two. Again, these are two tenants. And within the scope customer one, I have multiple collections, orders and shipping. And likewise for customer two, I can have orders and shipping, and each can contain different documents. And hence multi-tenancy can be very easily achieved with scopes and collections. So let's look at furthermore with the relational to NoSQL mind mapping. So if you have a table, so what about each row in a table? How do you map that? So each row in a table would be probably a document, right? So this is a row and it's probably a document. Okay. So what about the columns? So these columns are multiple attributes of different documents. Right? What about the entire table here? The entire table is what is represented by the collection. So all this, so within a bucket, you will have multiple collection, and within a collection, you will have multiple user documents. So this is a user collection. So I'm going to show multiple user documents within this user collection. Right? So what about a different table? So that's going to be in a different collection. So it's going to be a set of documents in a different collection. But remember, Couchbase is flexible. So which means you are storing your data in terms of JSON, and JSON is flexible. So you need not have different documents with exactly the same attribute. So I can have another document where restock is true and there's no attribute called as quantity here. It's quite possible. Okay. So let's talk about JSON physical data modeling. So when we are talking about physical data modeling, so there are various structural options in JSON data modeling. So the first thing is document type and versioning, under which we have the key design and document management fields. So you want to talk about how am I going to design the keys and how am I going to add certain extra documents that are used to manage the document itself. Other than that, I also have to take care of my document structure, and there are various choices for that. Say, for example, the choice of field name, length, style, consistency, the choice of root attribute versus type parameter, which we used to usually use in the previous version of Couchbase, okay, versus collection. So which am I going to use when, right? How am I going to treat objects? How am I going to talk about arrays? What about array element complexity? What about timestamps? How am I going to deal with them? What about various attributes that are valued, missing, empty, or null attributes? What about the schema, right? So first, let's look at the key modeling. So Couchbase is a key value pair, right? The data service stores the data or the JSON document in terms of key and value. So it has the key part and the value part, and both can be modeled. So you have the key as well as the data, and key takes up to 250 characters, and value can be up to 20 megabytes. It does not mean the value should be as large as 20 megabytes. We're going to talk about that little later. Usually, but not necessarily JSON, right? So typically the kind of document you're going to store in Couchbase is going to be JSON, but it's not necessarily JSON. So other than that, you also have the metadata. The metadata consists of various things like ID, expiration, cache, and other things like revision flags, types, and extra attributes where you can store in your own attributes. Let's talk about key modeling. When you're talking about key modeling, various customers treat keys in different ways. So you want to choose, or you want to make the key or design the key such that the first way of accessing the document is always by the key. So design your key such that the first way of accessing the document is always by the key. If that's not what you're looking for, that's when you have to look for nickel or other options. But always design the key such that the first way of accessing the document is by the key. So for example, here, I have prefixed the order document order :123 or product colon, say a UUID or something like this. The application name underscore the document type underscore the ID of the document, or something like the document type colon the parent ID colon the child ID colon say the ID of the document. So different ways of representing that. However, you need not go with this practice anymore if you're storing documents in terms of collection in Couchbase 7, wherein you can store different documents of different types in different collections. For example, here, the user profile collection has all the documents that are of type user profile, while tracks and playlists also have documents of their type respectively. So the earlier practice was I used to have a type attribute and all these documents were in a single bucket, right? So the way how I was going to distinguish between two different documents was by the type attribute, and that's no longer a practice in Couchbase 7 now, okay, while you're going to make use of Couchbase collections. So when you're talking about keys, the first choice of document keys should be your natural keys. So natural keys are basically the keys that exist in the real world. Like for example, phone numbers, username, social security numbers, account numbers, SKU, UPC or QR codes, device IDs. So of course you have to be very careful while working with any personally identifiable information or any kind of sensitive personal information or protected health information. You don't want to violate any of, say, the data rules or GDPR norms, right? So if you're not able to create natural keys, that is when you're going to choose surrogate keys. For example, for a user, email could be a natural key, SSN could be a natural key, phone number could be a natural key. But what about a pet? What about a playlist? That's when I'm going to choose a surrogate key. Well, surrogate key is used when no obvious natural key exists. Okay, they are usually derived from the application data, or they are usually generated, for example, SHA or UUID keys, right? So with Couchbase, we also have something called as atomic counters. You can make use of them if you want to generate atomic counters. Talking about the document management fields. Sometimes, so take a look at this document. So this is a document, say I'll call this as a user profile document. So sometimes you might want to store the metadata within the document. So what is this metadata? This metadata is not a part of the real data model, but you want to store this data to make something else work. Say, for example, make your backups more effective. For example, you might have a criteria where you want to back up all the documents that were modified only since 1st January 2021. So how are you going to keep track of them? You're going to store some information within the document, okay, which does not belong to the data model of this document, right? So examples of such attributes could be like type, version, created by. So you want to know when was this document created. So you're going to store that. You want to know when was this document last accessed, okay, or by whom was it last accessed. You're going to explicitly store this information within the document. This has been a very common practice by many customers to get a lot of things done, which is not something that's provided by default in Couchbase. Okay. So talking about the field name, length, consistency, and other things. So brevity is beautiful, especially at scale, right? So consider this attribute, geocode versus country code. So I'm going to choose geocode because country code takes probably 11 characters, while geocode takes only like 7 characters. So 7 characters versus 11 characters multiplied a billion documents is going to save so much space, both in the memory and the disk, right? So that doesn't mean that I'm going to choose an absolute attribute that doesn't make sense. So I'm not suggesting you to choose say CC instead of country code. So it's you need to still consider self documentation, right? So you don't want to choose something like uses login text. Just choose username. That makes more sense. Right? And use some consistent patterns like first name with the camel case or first underscore name, right? Or just first name. You can choose either of the one, but be consistent in that. Okay, make sure your arrays are in plural, while uh, while the singular attributes are just singular, just general attributes, right? So avoid using any kind of reserved words. For example, user or password is kind of reserved words. So you want to avoid using them. Try to avoid using special characters like hyphens here. So instead use first underscore name instead of first hyphen name, because in that case, then you'll have to enclose this within the backticks, because Nickel gets confused like if this is first minus name or first hyphen name, right? So other things like single root versus type or class parameter versus collections. So if you look at the previous version of Couchbase, we had various ways how you can store documents. Say this was the root element, right? So the root element used to identify the kind of document. So the root element of this document was track. So this identified that this document is a track document. While this document did not have a root attribute or a root element, but it had the attribute called as type, which is track. So the attribute type was the identifier of this document, that it belongs to the type track. While what is recommended in Couchbase 7 is you want to get rid of the type attribute, instead store this document in an appropriate collection. So I'm going to store this document in the collection called as track. So user profile will have all the user profile documents, while track will have all the track documents, while playlist will have all the playlist documents. Instead of me separating by the root element or the type attribute, I'm going to keep in their respective collections. Objects versus arrays. So look at the phones here. It's a simple object, while here it is an array of objects. So I'm not here to tell you which one is better. We might want to use both. But what is recommended is try to use simpler attributes, because remember, whenever you use array of attributes, Nickel has to still parse them. Every time you need to query a document, you need to parse them. So your practice should be to make the data model that's much simpler to understand for you as well as Nikhil to handle. I'm nowhere telling that you should not use array of documents. You can, we do have array of indexes, but what I'm trying to say here is it has a cost. So array element and the complexity. So look at this. In this case, I have array of track IDs. It's an array of strings, right? While in this case, it's an array of documents. So what happens here is, if I have to get the details of the track, every time I have to fetch using this track ID. So if I store the document in this model, I'll have to do multiple fetches, right? But in this case, you can see there is a single fetch because it's an array of documents. I just need to fetch this array tracks, and immediately I get to know all the information. I get to know the artist information. I get to know the genre, the ID, and the title of the document in one fetch, right? So what are the various other choices that I have for date? So when I'm storing date in Couchbase or in JSON modeling, so I have at least 3 formats where I can store. I can store date in, say, ISO 8601 format. I can store date in, say, epoch format, right? So, or I can store date in terms of array of time components. I again can choose whichever format I want to, right? So this format is much easier for displaying, while this format is much easier if you have to do some kind of operations like sorting. While this format is also much helpful if I have to, say, push this data to a time series kind of graph, right? So talking about data nesting now. So as you know, relational database promotes separating of data using normalization, which does not scale. But for NoSQL systems, we often want to relax the normalization. I don't want to use the term avoid. I want to use the term relax normalization so that you can scale. Where nesting allows related objects to be organized into hierarchical tree structures where you can have multiple levels of grouping. Okay, the rule of thumb is you don't want to do more than 3 levels of nesting, right? So you might also want to include timestamp in the nested data. So let me show you some example. So have a look at this document. So this is the playlist document, and this is a user profile document. Playlist document has an attribute called as owner, so which points out to the user profile document using the username, right? The owner refers to the username in the user profile document. So here I need to fetch. So if I need to know from the playlist document, what is the name of the owner or what is the email address of the owner, I need to do a fetch here, right? I have fetched this document already. I further need to fetch this document. But however, if I had nested the data, say something like this, I'm not nesting the entire document. I'm just doing a partial nesting. The documents or the attributes that I think that would be useful when I fetch the playlist itself, right? So now you can see here the owner document is nested here, or at least is partially nested, which has the phone number or which has the first name, the last name, and the username here, right? Let me take another example. So playlist and the tracks. Tracks is an array of strings. So every time I have to read a track, I need to do multiple fetches. So I need to do at least 3 fetches here to fetch the track ID, say the MP3, the genre, or whatever, right? So instead of storing something like this, what if I had nested the track documents, something like this, wherein I have an array of objects. Say I have the artist, genre, ID, and MP3 and title embedded within the playlist document itself, right? So I don't have to do multiple fetches now. However, be cautious about the size of the document. So by this time, you must have noticed that JSON data modeling is all about making trade-offs, right? So what is trade-off? So I had to just Google this, and I found some very interesting meaning of trade-off. So trade-off is a situation in which you must choose between or balance 2 things that are opposite or cannot be had at the same time, right? So trade-off is something that you do not want, but must accept in order to have something that you want. So what are the trade-offs that you do while you're data modeling in Couchbase? So Eric Brewer has already done, has shown the trade-offs in the CAP theorem, and Couchbase has already chosen its positioning in the CAP theorem. So that is, Couchbase is CP by default and can be CAP with the HDCR. Right? So what are the trade-offs that we as data modelers need to do while designing my data? So the trade-offs that I need to take up is with the document size, the atomicity, the complexity of the document, and the speed of access. Right? So I want probably a document that is very small so that I can access it fast, right? But if I have a document that's too small in size, then I would lose on atomicity because Couchbase is fully atomic at the document level, right? So if the document is too small, yes, I gain on the complexity, correct? But what about speed of access? I might have to do multiple fetches, so I might lose on speed of access. So what I'm trying to say here is I want to balance between these four things. Right? So document size. Couchbase Server supports document up to 20 megabytes. Yes, but that does not mean the document should be as large as 20 megabytes because remember, large document takes more disk space, more time to transfer across the network, more time to serialize and deserialize. So if you're dealing with documents that are potentially large, so you must test thoroughly to make sure the speed of access is adequate as you scale. If not, you might want to break down into smaller documents. Okay. Atomicity of the document. Atomicity in Couchbase Server is at the document level by default. Okay, if we are not talking about transactions. Okay, Couchbase does have transactions. They use them only when it's absolutely necessary. But if you want the changes to be absolutely atomic, you want to make it a part of the same document. But if you're making everything as a part of the same document, the document size is going to be large. Large document takes more time to transfer across the network, so your speed of access is going to be slow. So you don't want to make the document extremely large. You don't want to make the document extremely slow, right? So again, that's the trade-off, right? You want to test thoroughly so that the speed of access is adequate as you scale. So complexity of the document. So complexity affects every area, so including data modeling. So I'm not here to explain this nickel query, but the idea what I want to give you here is I don't want to write a nickel query that has multiple joins, multiple nests, multiple unnests. I want to keep my data model simple such that my access pattern is also simple. Speed of access. As it relates to data modeling, speed of access is very critical. So remember, the fastest way of accessing the data is by the key. And I always promote that you always should design the key such that the first way of accessing the data is by the key. And then your approach should be to go with nickel. Right? If you're implementing interactive use cases, you might want to avoid joins. I'm not telling you should not use joins. Again, I'm telling join comes with a cost. Right? Let's finally talk about embedding versus referring. So all the previous trade-offs rolls to a single question. Should I embed or should I refer? Right? So let's take this conceptual diagram. Okay. So you can see I have customer who has contacts, pay types, addresses, orders, items, products, right? So the question here is, now that I've identified my conceptual model, how am I going to design my logical model? So which basically means out of these entities, what are going to be my objects? Is this going to be my objects? Which means I'm going to have an order, which I'm going to have an array of items embedded within them, or should I do something like this, wherein I just have orders and items with only item and quantity, and I have them further referred to individual documents of type product, different multiple documents of type product. So either I'm going to go with this or I'm going to go with this. So again, these are not the only two ways. So this is what you need to identify as a part of your logical design, right? That's exactly what you want to decide on. So the question again is, whether should I embed or whether should I refer? How much should I embed or how much should I refer? So some common practices. So if your relationship is one-to-one or one-to-many, right? So uh, then you might want to nest the related objects. So if your relationship is many to one or many to many, then you want to refer. If you're reading mostly parents, right, then refer to children as separate documents. If you're referring more, if your reads are mostly both for parents and childs, you want to do in one fetch, so you nest them. Your writes are only to either parent or the child, then you're going to refer them, right? Keep them separate. If your writes are mostly together for the parent as well as the child, you're going to nest them. So I hope the session was useful and gives you some tips to uh, to model your JSON in a better way. Thank you, and these are my contact details.